All right, today we are looking at adding and subtracting polynomials. So learning goal, we're going to add and subtract. Success criteria, I can identify the parts of a polynomial, classify polynomials by the number of terms and the degree, write a polynomial in standard form, and finally add, subtract polynomials. All right, so let's get started. So to start with, we need some vocabulary. A monomial is a real number variable, or the product, meaning we're multiplying a real number and one or more variables with whole number exponents. So the whole number exponents part is important. We cannot have decimals or fractions in exponents. That will not make it a monomial. We also can't have negative exponents. The degree of monomials, it's the sum of the exponents in the variables. Okay, so for instance, something like x squared y to the third would be degree 5, because we take the 2 and the 3 and we'd add them together, and that would give us 5. A polynomial, poly meaning many, is simply a monomial, or a sum or difference, we're adding or subtracting, two or more monomials. And each piece, each monomial, is called a term. The degree of the polynomial is the greatest degree from any term. So for instance, if I had 6x to the 5th plus 3x to the 9th plus 4, at each term, I have 3 terms, 1, 2, and 3. I'm looking at the degree of each one, 5, 9, and the 4 actually has no term, so no exponent, so it's a 0. So the degree of this polynomial would be 9, because that's the highest. All right, so if we name them based on their degree, okay, naming based on the degree, a constant has degree 0. It's just a plain old whole number, 6. 12, 37. Something that's linear has degree 1, and an example of that linear term would be 5x, because remember there's that invisible 1 as an exponent. Something that's quadratic has a degree of 2, and so somewhere in the degree it has a highest degree of 2. So this polynomial has degree 2 because that 2 is the highest exponent, the highest degree of a term. Cubic is degree 3, and again, this is 2 and 1. We add those together, that gives us degree 3. Now, constant, linear, quadratic, and cubic, those are the ones you're going to see most often, but we're showing you the next 2 words simply so you know they exist. Something that's of the 4th degree is called quartic, and so you're somewhere going to have a 4th exponent, 8x to the 4th plus 3y. Okay, that x to the 4th is what gives us degree 4. And then quintic, 5. So as I'm looking, let's see, this is degree 1, 5, and then that would be degree 2, but 5 is the highest, so that's why it's the 5th power. After quintic for 5, we typically just call things by their degree, their number. So something that's the 6th degree, maybe we had a x to the 4th y squared plus 3. So here's my 4 plus 2, gives us that degree of 6. All right, so quite a bit of vocabulary here, but just go with what you know, and we'll build on it. All right, we can also name polynomials based on the number of terms, and there's not as many names here. Monomial, binomial, trinomial, and then simply polynomial. Okay, mono, one term, so something that just has one piece, 3x. A binomial, like a bicycle, how many wheels does a bicycle have? 2. So my binomial has to have 2 terms. 6x plus 11. So 2 terms, 1, 2. And again, my terms are separated by addition and subtraction. A trinomial, just like a tricycle, when your younger siblings are riding a bike, or in some cases you're older adults. My mother may be known to ride an adult tricycle at times. Tricycle has 3 wheels, so a trinomial has 3 terms. 8x squared plus 3x plus 4. Okay, there's 1 term, 2 terms, 3 terms. Anything beyond 3 terms is simply called a polynomial, so 4 or more terms. So 18x to the 4th plus 3x squared minus 9x plus 2. We've got 1, 2, 3, 4 terms, polynomial. Alrighty. Now let's get into standard form. Standard form of polynomial is the form of a polynomial in which the degrees of the terms, or the terms actually, are written in descending order according to their degree. So we're going from highest exponent to lowest exponent, high to low. So let's see, my highest exponent, we've got a 2, we've got a 4, we've got a 1, and we've got a 5. So my negative 7x to the 5th is going to go first. And let's see, so we're at 5, now we have to work our way down. Exponent of 4 is next. So minus 5x to the 4th. 5, 4, 3, I don't have any exponents of 3, but I do have a 2. So that 3x squared, now there's no term in front, so we know that's really a positive, so plus 3x squared. And then the last term is simply 8x, so plus 8x. Okay, that's standard form. As I look at my exponents, we're starting with the highest, 5, and we're going down to 4, and then 2, and then 1. That is standard form. All right, adding polynomials. We are simply combining like terms. We don't change any exponents. Like terms have the same variable and exponent. Okay, now I'm going to do each problem here twice because you can do them vertically or horizontally. I'm going to start with horizontally, simply combining my like terms, the things that look alike. Okay, so let's see. I'm going to start with my x to the 4th, because that's my highest exponent. So I've got 2x to the 4th plus 5x to the 4th. Well, 2 plus 5 is 7, so I now have 7x to the 4th. And then I've got negative 3x plus negative 1x, so negative 3 plus negative 1 is negative 4, so negative 4x. Okay, that's in standard form because I'm starting with the x to the 4th and then moving down to the x term, so I'm done. So that's one option. The other way you can do it is you can line them up vertically like we do a longer addition problem. Okay, so if I were doing this vertically, I'm going to take my negative x and I'm going to put it under my x term. I'm going to take my 5x to the 4th, put it under my x to the 4th term. And now I'm simply adding vertically. 2x to the 4th plus 5x to the 4th is 7x to the 4th. And negative 3x plus negative 1x is negative 4x. Okay, so you notice I've got the exact same answer, doing it 2 separate ways. Your preference on which you like better. All right, another addition example. So let's see, like terms, same variable, same exponent. Negative 2a to the second. I don't have any other exponents that are a squareds, so that just becomes part of my answer, negative 2a squared. Next terms, I've got positive 3a and positive 7a. So 3a plus 7a is 10a. And then I'm down to my constants, negative 5 plus positive 5. Well, negative 5 and 5 is just 0. So that cancels out. There's nothing. So I'm left with just negative 2a squared plus 10a. Okay, if I do it vertically, there's my first trinomial. And then I'm going to line up my second binomial under my like terms. So my 7a is going under my 3a, and my positive 5 goes under my negative 5. And then I'm simply adding. So that drops down to my answer, negative 2a squared. 3a plus 7a is 10a. And negative 5 and positive 5 cancel. So negative 2a squared plus 10a. Again, two ways to do the same problem. All right, subtracting polynomials. Think about distributing a negative 1 to each term. Then it's simply an addition problem. Combine like terms, don't change any exponents. So if I think about distributing this negative 1 to each term, well, let's see, negative 1 times negative x is positive 1x, and negative 1 times positive 5x to the fourth is negative 5x to the fourth. And then my first binomial was 2x to the fourth minus 3x. So now I'm simply combining like terms. 2x to the fourth minus 5x to the fourth is negative 3x to the fourth. And then negative 3x plus 1x is negative 2x. Okay, if you're doing this vertically, 2x to the fourth minus 3x. And then again, remember, we're subtracting, so I'm going to change these signs. This becomes plus 1x, and I'm putting it under my x term. And this positive 5x to the fourth became negative 5x to the fourth. 2 plus negative 5 is negative 3, x to the fourth. Negative 3 plus 1 is negative 2x. And you're done. Again, two ways to solve the same problem. You choose what works best for you. All right, subtract 7a plus 5 from the quantity negative 2a squared plus 3a minus 5. All right, so that from is important. That means we're starting with that quantity negative 2a squared plus 3a minus 5. We're subtracting 7a plus 5 from that. All right, it's subtraction, so we're thinking about distributing that negative 1. So I'm going to change this to plus, and that means this becomes negative, and this becomes negative. All right, let's see. So I'm going to put my negative 7a under my 3a, and I'm going to put my negative 5 under my negative 5, and do what it says. Negative 2a squared minus 4a minus 10. There we go. All right, now we're going to throw a term at you that you intuitively already know, but we got to give it a name. So the closure property states that polynomials are closed under addition and subtraction, and we'll actually add one more operation as we move through this unit, because the result of these operations is always another polynomial. So in other words, I take whatever polynomial I want. 6x squared plus 5x. And if I add it to another polynomial, 2x squared minus 3x, my result, let's see, 8x squared plus 2x, that's another polynomial. So because that's always the case, you will never find a way that that doesn't work, that means that the closure property works for addition and subtraction, okay? The operations of addition and subtraction are closed within the set of polynomials. All right, take a minute, perform each operation, and then name the resulting polynomial based on its degree and number of terms. Don't forget to pay attention to, is it an addition or a subtraction problem? All right, so feel free to pause this video, try these on your own, and then come back and check your answers. We'll work through those together in a moment. All right, I see a subtraction sign, so I'm distributing a negative 1, so that becomes a plus, a negative 3w, and a negative 7. So let's see, my negative 3w comes under my other w term, my negative 7 comes under my 8. So we've got negative 2w to the 4th minus 6w plus 1. All right, so let's see, naming it. Well, it's a 4th degree, so that means it's a quartic polynomial because it's the 4th degree. And then there's 1, 2, 3 terms, so it's a trinomial. So its name is a quartic trinomial. All right, let's see, it's an addition problem, so I am not changing any names. And because I'm getting into a larger problem here, I will typically do these vertically. So my 2x is going under my negative 7x, my negative 5x squared, and my positive 3. So we got 3x squared plus 4x cubed minus 5x minus 6. All right, now before I look at a name, remember my terms have to be in order from highest degree to lowest. So if I look at these, I'm currently going 2, 3, 1. I had to go put my highest term first. So I need to put this 4x cubed first, and then my 3x squared, and then my negative 5x and my negative 6 are still last. So now I may give it some names. My highest degree is 3, so that means it's cubic. And then let's see, how many terms are there? 1, 2, 3, 4. So 4 terms does not have a special name, it's just a polynomial. All right, there we have it.